Have you ever looked up at the night sky and wondered what secrets it holds? We often think of space as a vast, predictable clockwork, governed by the elegant laws of gravity laid down by Newton and Einstein. Planets orbit stars, moons orbit planets, and comets follow their long, lonely paths. But what if I told you there's an object out there, a cosmic traveler that seems to be playing by its own set of rules? What if something is accelerating through our solar system in a way we can't fully explain? Today, we're diving deep into one of the most intriguing astronomical puzzles of recent times, the strange case of Comet 3I-ATLAS. This isn't just another icy rock. Its bizarre behavior has scientists scratching their heads and has even sparked whispers of something far more extraordinary. Is it a natural phenomenon we've never seen before, or something else entirely? Stick around, because the story of 3I-ATLAS is a journey to the very edge of our understanding. First, let's get acquainted with our mysterious subject. The comet was discovered in late 2019 by the Asteroid Terrestrial Impact Last Alert System, or ATLAS for short, a robotic survey system in Hawaii designed to spot near-Earth objects. When it was first spotted, it was just a faint smudge, designated C2019Y4, but it quickly got astronomers excited. But then, something strange happened. Instead of continuing its magnificent display, 3I ATLAS began to fade. In April 2020, just as it was supposed to be reaching its peak brilliance, observations from the Hubble Space Telescope confirmed our fears. The comet was disintegrating. It had broken up into several smaller pieces. This in itself isn't totally unusual. Comets are fragile, dirty snowballs of ice, dust, and rock, and the intense heat and gravitational forces near the sun can tear them apart. The dream of a great comet was over. But as one mystery ended, a far more profound one was just beginning. While the breakup was disappointing, the real scientific puzzle emerged when astronomers analyzed the comet's trajectory before it fell apart. This is where things get truly weird. When we track an object in space, its path is primarily dictated by the gravitational pull of the sun and the planets. It's a cosmic game of billiards, and with our understanding of gravity, we are incredibly good at predicting where the balls will go. Comets, however, have a little trick up their sleeve. As they get closer to the sun, the ice on their surface turns directly into gas, a process called sublimation. This gas shoots out in jets, creating the comet's beautiful tail and coma. Think of it like a tiny, natural rocket engine. This outgassing can give the comet a gentle push, causing it to deviate slightly from a purely gravitational path. We call this non-gravitational acceleration, and for most comets, it's a well-understood and predictable effect. But 3I ATLAS wasn't like most comets. It exhibited a significant acceleration that couldn't be explained by the standard outgassing model. The push it was getting was far stronger than what its observed activity, the amount of gas and dust it was visibly shedding, could account for. It was moving as if it had a hidden engine, a force that wasn't showing up in our telescopes. The data was clear. The comet was accelerating, but the why was a complete blank. This discrepancy sent a ripple through the astronomical community. The fundamental rulebook of cometary physics didn't seem to apply here. So, what could be causing this? Scientists began scrambling for explanations. One of the first ideas was that the outgassing was happening in a very unusual way. Perhaps the jets of gas were invisible. Water ice, a primary component of comets, sublimates to produce water vapor, which is transparent and very difficult to detect directly from Earth. If 3I-A-TLAS was spewing out huge amounts of water vapor from a single powerful jet on its dark side, the side facing away from us, it could potentially produce the observed acceleration without a corresponding visible display of dust and other gases. It's a plausible theory, but it would require a very specific and conveniently hidden configuration. It's an explanation that fits, but it feels a bit too perfect, a bit too lucky. Another theory revolves around the comet's breakup. Could the acceleration be a result of the fragmentation process itself? When an object breaks apart, the pieces fly off with some velocity. It's as possible that the main fragment we were tracking received a significant kick when a large chunk broke off. Imagine a spinning ice skater pushing away from a partner. Both move in opposite directions. In this scenario, a massive piece could have broken off and been thrown backward, propelling the remaining nucleus forward. This would explain a sudden change in velocity. The problem is, the acceleration of 3I-ATLA has appeared to be smooth and continuous over a period of time, not the result of a single explosive event. The data points to a sustained push, not a sudden shove. This is where the story takes a turn toward the truly speculative, the kind of stuff that makes science so exciting. Frustrated with conventional explanations, some researchers started to think outside the box. What if the acceleration wasn't from outgassing at all? What if it was something else entirely? This led to the revival of a very old and controversial idea. The 3I-ATLAS was not a comet in the traditional sense. This is where we enter the realm of the truly extraordinary, stepping away from familiar territory. One of the most captivating, albeit highly speculative hypotheses was put forward by astronomers Avi Loeb and Amir Siraj from Harvard University. They pointed to the bizarre case of Oumuamua, the first interstellar object ever detected passing through our solar system in 2017. Oumuamua also showed non-gravitational acceleration without any visible outgassing, and its strange, elongated shape led Loeb to propose that it could be an artifact of an extraterrestrial civilization, perhaps a light sail, a thin probe pushed by starlight. Could 3I Atlas be something similar? The acceleration was a key feature it shared with Oumuamua. While 3I Atlas was on a cometary orbit and not interstellar, its unusual behavior made some wonder if we are looking at a similar phenomenon. Could it be an object of artificial origin, masquerading as a comet? The idea is that a very thin, lightweight probe could be accelerated by the gentle pressure of sunlight itself, a process called solar radiation pressure. For a natural object like a comet, this effect is negligible. But for a specially designed, ultra-thin craft solar sail, It could be the primary means of propulsion. The acceleration of 3I Atlas, while strong for a comet, was in the ballpark of what you might expect from such a technology. Now, before we jump to conclusions, it is absolutely crucial to state that this is an extraordinary claim, and extraordinary claims require extraordinary evidence. The vast majority of the scientific community believes there must be a natural explanation for the behavior of 3I Atlas, even if we haven't found it yet. The idea of an alien probe is a hypothesis of last resort, something to be considered only after every single natural possibility has been exhausted. Science thrives on skepticism, and jumping to an alien explanation is often a sign that we just haven't been creative enough in our search for a natural one. So, let's pull back from the fringe and look at the most likely scenarios. The leading natural explanation remains some form of unusual outgassing. Perhaps the comet's composition was different. Maybe it contained a large amount of a supervolatile ice, like molecular hydrogen or nitrogen, that could sublimate far from the sun and produce a powerful, invisible thrust. Or perhaps the comet's rotation and the location of its active jets were aligned in just the right way to create the acceleration we saw. The fact that the comet ultimately disintegrated might even be a clue. Its structural weakness could be linked to its unusual composition or internal activity that led to both its breakup and its strange acceleration. It might have been a dud comet, internally unstable from the very beginning. The legacy of Comet 3I Atlas is not that it was a spectacular sight in the sky, because it wasn't. Its true legacy is the questions it forced us to ask. It served as a powerful reminder that the universe is still full of surprises, and that our models are never complete. Every time an object like 3I Atlas or Oumuamua comes along and breaks the rules, it forces us to refine our understanding of the cosmos. These anomalies are the engines of scientific progress. They push us to look closer, think harder, and develop new tools and theories. Will we ever know for sure what caused 3I Atlas to accelerate so strangely? Perhaps not. The evidence, the comet itself, has been destroyed, scattered into a cloud of dust and gas that will slowly disperse along its old orbit. We can't go back and take another look. All we have are the few months of data we collected as it made its final fateful journey. But the puzzle it left behind will continue to inspire astronomers for years to come. It's a celestial cold case, a mystery written in the language of orbital mechanics. And in the end, that's what makes space exploration so compelling. It's not just about finding answers. It's about discovering ever more beautiful and profound questions. Whether 3I Atlas was a bizarre natural fluke or something more, its brief and enigmatic passage through our corner of the universe has left an indelible mark on our curiosity. It reminds us to keep looking up, to keep wondering, and to never assume we have it all figured out. Thank you so much for joining me on this deep dive into one of astronomy's most curious recent puzzles. If you enjoyed this journey to the edge of our knowledge, please consider hitting that like button and subscribing to the channel for more stories from our amazing universe. Let me know in the comments what you think. Was it a weird comet or something more? Until next time, keep your eyes on the stars.